Can these simple wooden clothespins be turned into something useful? Today, I'll reuse these wooden clothespins along with a few common materials to create a simple but surprising DIY project. Let's see how it turns out. First, I'll use a marker to mark the drilling points on the wooden clothespins to prepare them for the next fabrication step. For the fourth clothespin, I'll mark it slightly differently because I plan to reuse it as a wire stripping tool. Next, I separate the wooden pieces of the clothespins to make the drilling process easier and more precise. Then, I carefully drill small holes at the marked positions, creating the mounting points needed for the next assembly steps. This video is for DIY and educational purposes only. Projects involving soldering, heat, and electricity can be potentially dangerous. Always use appropriate protective equipment and follow proper safety procedures when working. Here, I have a pencil sharpener, and I'll reuse its metal blade as the cutting blade for my wire stripping tool. First, I remove the metal blade from the pencil sharpener. Then, I attach the blade to the hole I drilled in the wooden clothespin and secure it in place. With its sharp edge, the clothespin can be repurposed into a simple wire stripping tool for removing the outer insulation from wires. In the next step, I prepare small screws and install them into the holes I drilled in the 3 wooden clothespins. These screws help secure the components and create stronger connection points for the assembly. Every like and subscription motivates me to create more creative DIY projects. Thank you so much for your support. Next, I use a wooden block as the central connection component of the system. First, I drill 3 small holes into the wooden block to create mounting points for the 3 clothespins. Then, I attach the 3 wooden clothespins to the 3 drilled positions and adjust them so they are securely positioned, forming a compact connection assembly. Next, I cut a small piece of metal from a soda can. This metal piece will be reused as a linking and reinforcing component for the wooden block assembly. Then I place the metal piece on the surface of the wooden block and drill 2 holes near both ends. These holes create mounting points for the screws and help keep the metal piece firmly attached to the wood. Next, I insert 2 screws into the 2 holes and tighten them to secure the metal piece to the wooden block, completing the central structure of the device. In the next step, I use 2 copper wires to link the connection points on the wooden clothespins. I wrap the copper wires around the screws on each clothespin to create secure contact points and connect the components together. This arrangement helps create a continuous path between the connection points while keeping the system more compact and stable during assembly. Next, I wrap one end of the copper wire around the screw that secures the metal plate to the wooden block. I repeat the same process with the other copper wire to complete the 2 connection paths. In the next step, I'll repurpose a nail clipper to build the frame of a small soldering device. First, I remove the original handle piece to prepare it for assembly. Then I replace it with a securely fixed bolt. The bolt will be repurposed as the heating element of the device. Next, I repurpose the metal core from a terminal block as an intermediate component between the heating section and the soldering tip. Once I remove the metal core, I insert it into the bolt of the heating section and tighten it with a nut. This helps secure the components firmly and creates a stable connection point for the soldering tip. Next, I prepare a long electrical wire to serve as the power lead for the soldering device. First, I strip a longer section of the insulation to expose the copper conductor inside. Then, I divide the exposed copper strands into 2 separate groups to make the connections easier. Next, I twist one group of copper strands and secure it to the small hole in the nail clipper to create a firm contact point. For the other end of the wire, I attach a large alligator clip. The alligator clip provides a convenient connection point between the soldering device and the power source while also making the system easier to connect, disconnect, and inspect. Next, I'll repurpose an old battery to make the soldering tip for the device. First, I use pliers to remove the outer metal casing of the battery. Next, I use needle nose pliers to grip the carbon core inside and slowly twist it out of the casing. Then, I use a paper towel to clean the surface of the carbon core, removing any dirt and residue. In the next step, I attach the carbon core to a drill to prepare it for shaping. I run the drill and gently bring the end of the carbon core into contact with the sandpaper to grind and shape the tip. Grinding the end creates a smaller and more compact contact point, making it better suited to the soldering tip design and allowing it to contact the area being heated more easily. After finishing the soldering tip, I put the components back together and tighten the screws to secure the casing. Because the nail clipper is made of metal, I wrap electrical tape around the handle and other metal areas that may come into contact with my hand. This adds an extra layer of protection and helps reduce direct contact with conductive metal parts during use. Because the metal plate on the wooden block is secured with two metal screws, they create a continuous electrical path, causing the current to remain connected across the surface of the metal plate. Therefore, I cut a section in the middle of the metal plate to break the connection and create two separate contact sections. Then, I apply strong adhesive to secure the two ends of the metal plate in place, making the structure more stable. In the next step, I use a battery as the power source for the soldering system. Then, I connect the electrical wire from the system to the battery to prepare for testing. As soon as the soldering tip makes contact with the connection point, a spark immediately appears. This indicates that the system is producing electrical current and heat at the soldering tip, allowing me to continue with the following tests. In the first test, I will check the ability to join two razor blades. After completing the joining process, the two metal pieces are secured together. I then test the strength of the joint to see whether the two metal sections remain stable. In the final test, I will repair the broken handle of a metal cup. First, I prepare a small piece of metal cut from a razor blade to use as reinforcement. Then, I place the metal piece over the broken section of the handle and secure the two parts together. After completing the reinforcement, I inspect the handle again. The result shows that the handle has been secured back in place, and the joint remains fairly strong under a light test. So, the homemade soldering machine is complete and works as expected. If you enjoy DIY projects like this, don't forget to follow for more.